Good day. Welcome all for the lecture series on programming for problem solving. Okay, I am Dr. Kotlingam with SRM IST. See, in the previous lectures, we have seen about evolution of programming and languages as well as introduction to problem solving through programming. So now we are in the phase of seeing about creating algorithms. See, before moving to the parts of saying about algorithms or the concepts of algorithms, let us go with the definition of algorithms. An informal definition of an algorithm is a step-by-step method for solving a problem or doing a task. See, let us begin with a very simple definition. An algorithm is an outline of the steps that the program has to take or any computation procedure has to take. See, basically a program is an implementation of an algorithm. That is, a set of instructions can be converted into a procedural way which is called an algorithm. And every program takes an algorithm to execute. For any given problem, you can create an algorithm to solve it. From the start to the end, you can have steps, you can have instructions to solve the problem, and which can be used in any programming language to solve the given problem. Let us start with the fundamental question. Given certain problem, how do you solve it through computers? Yes, algorithms will give answers for that. Yes, algorithms will give answers quickly when you do it through a procedure way. It takes an input data and process with its step-by-step procedure and gives an output. What are algorithms for? A way to communicate about your problem solution with others. Whenever there is a problem, whenever there is a given problem, we need steps to solve it, which we call it as a way to communicate to the solution, to attain the solution. It is the only possible way to solve a given problem. It is a formula or a set of methods or a set of procedures or a set of itineraries that will be proved. Every formula can be proved. So basically an algorithm is a formula or a formalization of a method. See, before implementing any solution through a programming language, you need an in-hand algorithm. An in-hand algorithm is a set of instructions. See, the definition given for an algorithm is a finite sequence of unambiguous executable steps or instructions which, if followed, would ultimately terminate and give the solution of the problem. At this juncture, I recommend to read the book Introduction to Algorithms by Forman. This is one of the fantastic books available in the market to know about algorithms. Before seeing about the notations, I would like to say something about algorithms. An algorithm is said to be correct if for every input instance it halts with the correct output. Once you give an input, it needs to halt on the right output. We say that a correct algorithm solves the given computational problem. An incorrect algorithm might not halt at all on some input instances. So if your algorithm is not proper, and by no way you can halt at the right output, it will keep on execute. Else it will keep on execute the wrong solution. Or it might halt with an answer other than desired one. Yes, if it is incorrect, we ended up in getting an undesired one. The unexpected answer can be unnecessary answer can be attained through an incorrect algorithm. See, every algorithm has certain notations: a starting point, step numbers, incoming information. The starting point is the start of the algorithm. I mean, the initial procedural step to start an algorithm. Step numbers for every single step, where every single instruction can be made as steps. You should have step numbers or instruction numbers. Step 1, step 2, step 3, instruction 1, instruction 2, instruction 3. Until the end of the algorithm, you have to give steps for every single procedure. Incoming information, that is the data you want to process with the algorithm. That is called input or incoming information. Control flow or order of evaluating the instruction. In which order you have to evaluate? Basically, in mathematical perspective, there are operator precedences there. That is one of the examples. We can say if for order of evaluating the instructions. If suppose you want to add two numbers a plus b and you have to assign it to c, this operator precedence plays a vital role, which you need to add a and b and you have to assign to c, and which operator has to proceed first and which operator has to proceed next, which is called a control flow. Statements. There are n number of statements you can give it in an algorithm. I mean, with respect to your control flow, you can assign statements. Outgoing informations. What is the solution of the problem? That is called an outgoing information or an output attained after generating an algorithm. I mean, or a fruitful result which we attain from an algorithm, and which is also called the ending point of the. I mean, it has to halt. I said no, it has to halt. The algorithm has to halt. After attaining the respective solution, you have to give an instruction to halt the algorithm. This halting is in the sense the program has to stop after the concerned output has been attained. Properties of an algorithm: finite, complete, correct. The algorithm must eventually terminate. Yes, at one point of time after attaining the desired solution, it has to stop. That is, it has to terminate. Complete. Always give a solution when one exists. You should not, give. If suppose you have drawn something, suppose you made an algorithm, it has to give a solution. It has to give a solution. I mean, every algorithm has a solution. You cannot draw an algorithm without giving a solution. Even if it is right or wrong, it has to give a solution. Correct. Always give a correct solution. See, this complete and correct are correlated. It has to give a solution as well as it has to give a correct solution. Rules for writing an algorithm. Be consistent. Have well-defined input and output. Do not use any syntax of any specific programming languages. I mean, while writing the algorithm, your algorithm needs to be consistent. I mean, it has the aspects of running in a specific programming language, or it has the aspects of it can run in any number of programming language, because no algorithms are designed with respect to a specific programming languages. Algorithms are designed with respect to a specific problem. Have well-defined input and output. See, you have crafted a well-defined algorithm. If you are not giving the right input, I mean, there is no correlation between and giving a wrong input to a right algorithm or a right input to a wrong algorithm. There are hiccups will be there. There are mismatches will be there. So while drafting the algorithm, you should decide about what input you are going to give to an algorithm, and you should not design an algorithm with respect to a specific programming language. See, these are few steps in algorithm development process. Step number 1: obtain a description of the problem. You should observe the problem. You should understand the problem. That is step number 1. Analyze the problem. Fine. What is an exact terminology, and what is an exact issue in a given problem, and what we need to address it. That is called analyze the problem. Develop a high level algorithm. See, your algorithm must be high level in the sense it is the any level, it is the complete level. You should not have refinement. You should not have next level of an algorithm. I mean, for solving one problem, you can have n number of algorithms. You have n number of algorithms, but you should choose with respect to which is optimal and which is feasible and which is fast. So these things says that whether your algorithm is high level or not. Refine the algorithm by adding more details. After drafting the algorithm, you have to check what variables can be assigned and what functions can be used. If we use this function, it will run in this time. If we use this function, the number of lines will be reduced. So such a way you have to correlate for refining the algorithm. Review of the algorithm. Before making it into a programming language, you should review all the components from start to end, to the control flow, to the statements, and every single component in an algorithm must be reviewed before running the algorithm. See, we have given an example here. To develop an algorithm for finding the largest integer among a list of positive integers. See, this is one common example can be used for explaining algorithms. To solve this problem, we need an intuitive approach. First, use a small number of integers, then extend the solution to any number of integers. For example, it is 5. The algorithm receives a list of 5 integers as input and gives the largest integer as output. You can see the tabulation here for an output data, and in the left side you can see how the algorithm propagates. In the right side, the steps are given very clear. We have numbers as 12, 8, 13, 9 and 11. We are taking the first number as the largest number and comparing with the next number. If it is low, it has to continue. If it is high, it has to replace. By such a way, if the 12 has been compared with 8, then it is low, then again it remains as 12. The 12 has been compared with 13, it is high. Now the largest number has been replaced to 13. Now 13 has been compared with 9, so it remains 13 since because 9 is low. Then 13 is compared with 11, so still it is less, so it continues 13. This is the proper way to find the largest number within a given set of numbers. Example 2, print 1 to 20. Step 1 is start, step 2 is initialize x as 0, then increment by 1, this x has to be increment by 1, then print x. Until 20, you have to do the same process again and again. Why? Suppose that if x is greater than, if x is greater than 20, you have to halt and you can print all the n number of 1 to 20. It is stop. So these are list of given examples. You have to work it on home. Thank you. See you on the next lecture.